Hello and welcome to Toxic Tidbits. Today I'm going to show you how to calculate the toxic dose of methanol. But first, what is methanol? Methanol is an alcohol that's commonly used as a chemical solvent and can sometimes be a component of certain windshield washer fluids. It can also be found in improperly distilled ethanol or moonshine, and more recently has been a contaminant of certain hand sanitizers. Methanol is referred to as one of the toxic alcohols because it is metabolized in the body to toxic acid metabolites. In the case of methanol, being formic acid, which can cause things like blindness, neurotoxicity, severe metabolic acidosis, and death. So how much methanol would someone need to ingest in order to cause toxicity? In order to solve this problem, we need to look back to some of our basic pharmacokinetic equations, looking at concentration equal to the dose over the volume of distribution. There are several parameters that we already know, the first being the volume of distribution, which we can look up in any textbook and see that for methanol, it's in a range of 0.6 liters per kilogram up to about 0.72 liters per kilogram. But for the purposes of this presentation, we will use a value of 0.7 liters per kilo. The next thing we need in order to solve this problem is the toxic concentration of methanol. Serum methanol concentrations greater than 25 milligrams per deciliter are known to be associated with toxicity. And based on this, the American Academy of Clinical Toxicology recommends treatment for any patient presenting with a plasma methanol concentration greater than 20 milligrams per deciliter. So going back to our question, if we use a toxic concentration of 20 milligrams per deciliter and a volume of distribution of 0.7 liters per kilogram, then we just need to calculate the dose of methanol. Let's assume that we have a toddler with a weight of 15 kilograms. How much methanol would they need to ingest in order for it to be concerning to us? Looking back to our equation of concentration equal to dose over volume of distribution, we can plug in our known values and then calculate out the dose. So as you can see, we start with 20 milligrams per deciliter equal to the dose, which we're going to calculate, over the volume of distribution being 0.7 liters per kilo multiplied by 15 kilograms. As we carry through this math, we'll eventually get to a dose of 2,100 milligrams being our toxic dose of methanol, or 2.1 grams. But we're not quite done yet. So now we need to figure out how many mLs would that be. Most windshield washer fluids and methanol-containing compounds have a concentration close to about 37% methanol. 37% methanol means that for every 100 grams of the product, it would have 37 grams of methanol. So if we take 37 grams over 100 grams, and using the specific gravity of methanol, which is 0.8 grams per ml, and convert that then to milliliters, we get that there's 37 grams of methanol in every 125 milliliters of that liquid. And if we follow through the math, and we see that we need a dose of 2.1 grams out of that liquid, we'll get a final answer of 7.1 mLs of that windshield washer fluid to be a toxic amount to our 15-kilo toddler. When you consider that a teaspoon has a volume of about 5 mLs, it's a very small amount that can cause a lot of significant toxicities to a young child.